All right. So in lesson 9.2, guys, it says theoretical and experimental probability. Now, this is interesting because you know what? Remember what I told you guys before about the Florida lottery, right? The Florida lottery, there's a 0.00000. I'm not sure how many zeros are there. Chance that you will ever win the lottery. I mean, chances are that you will never win the lottery in your lifetime, or even the next generation, and the next generation, and the next generation. Probably will never happen. But what if then somebody just for once, just for the very first time, they go ahead and play the lottery. Like I said, this is an example. I'm not endorsing this. They go ahead and play for the first time and they win it right away, only on the first try. Okay, so those are the two things called theoretical probability and experimental probability. Theoretically, you should never be able to win the lottery. That's theoretically. There's like a no way chance in the world that you're going to ever win the lottery. The experimental is that you actually try it, and let's say after the second chance, you win it. So you mean to tell me that, okay, no, there's a 50% chance that you win the lottery? No. It's just with the trials that occurred, that's what's called experimental. Theoretically, is what should occur. You guys understand that? So the first part, when we talk about theoretical, okay, is what should happen when conducting an experiment. When conducting an experiment. Experimental is what actually happened when conducting and what actually happened when conducting an experiment. Alright, so this is what it is. So in other words, let's say if we have a spinner, okay? Let's say this is my spinner, and my spinner, we have green, we have red, we have yellow, and we have blue. And this is my little arrow. Okay, that's my little arrow. So according to this, let's say I'll give you an example. If you spin and get a green, you win the game. You win the game. Let's say that's the rule. So theoretically, what should be the probability of getting green? Which is 1 over 4. Correct? But let's say one of you guys, you play the game, and experimentally you go ahead and do it, and you get it 50% of the times. So you mean to tell me that it will contradict the theoretical part? Is that the case? No. No, it does not contradict that part right there. Meaning that just because you got it the 50% of the time, so like you did it once, oh man, I'm lucky. It's random. And you do it again the second time, oh, I won the game again. Correct? It doesn't mean that this is fault. There's a faulty error in this part right here. Theoretically speaking, you should always be able to win it 25% of the time. However, you were winning the game 50% of the time. Can anybody explain to me what's happening here that will cause a discrepancy over here? Yes?
You don't have enough trials, so you have to keep on spinning.
Very good.
You have enough trials, and then you can find real probability.
Very good. Guys, just because of the fact that you just do it once or do it twice doesn't mean that you will always get it 50% of the time. Theoretically speaking, your experimental should always align with the theoretical part. It should always align. Now, the only way for it to align is if you do more trials. Let's say you did it twice. You did it once, you did it twice. Oh, I'm winning the game 50% of the time, but you did it only in 2 shots or 4 shots, spinning it. But then again, it was like, you're not going to say, oh, I'm a lucky person, I'm always winning it 50% of the time. No. If you were to increase the trials, all right, if you were always to increase the trials more time, then you'll see that the theoretical part will always, the experimental part will always line up with the theoretical part. Think about this, when we flip a coin, okay, when we flip a coin, and I'm going to use this as an example, and let me go write this down real quick, so you guys can know. In order for this to work, all right, if you increase the number of trials, then the experimental will align is ALL, right?
No, it's ALINGN. It's ALIGN.
Yeah, that looks right. Mm-hmm.
I'm not sure. Those are one of the words with 2 L's or 1 L's. All right.
Yeah, it's 2 L's. No,
Can't spell
No.
I think that's right. It's one.
All right. Well, you guys get the idea. Okay.
I think I'm good.
So it's like that. Will align with the theoretical. All right. It will align with the theoretical. An example that I'm going to give you is this. All right. So one trial that you guys always know because you guys have done this before. All right. Is this. If we take, for instance, and one of the biggest parts for the trial, this is very important. All right. You guys are done?
Yeah.
Okay. In order for this to work, okay, you got to keep in mind something. That, how's the word I'm trying to find? I can't, it's on the tip of my tongue. Basically, whatever you're using for the trial, for instance, I'll give you an example. Let's say if you have a die and you're rolling the die. Dice, yeah.
Oh, dice.
And you roll it. But if you have like magnets on the dice that when you roll it, it has a tendency of rolling to on top of a 3. Then the dice that you guys are using is not a fair one. You guys, so whatever you're using for the trials, it has to be fair. Every outcome should have the same probability of getting picked. You guys understand? So, sometimes people say, oh, you cheated. Well, probably because of what they're using, to go ahead and roll or to go ahead and choose. It benefits them in the long run. You guys understand that? So that's why you have to be very careful when you're rolling or whatever. Is it fair? It's like some people have talked about, is the lottery fair when the little balls are bouncing over there? If one ball weighs more than the other ball, then chances are that ball is not going to fly up enough to get picked. all the balls in the lottery system, they have to be the same weight. They have to have the same size, because if not, you don't have an equal chance of being picked. You guys understand that? So that's very important. So in the trials, everything that you had to do, it has to be uniform. All right. So that's the first part. But let's go back to this experiment. All right. The experiment of flipping a coin. Well, you just said it's a 50-50 chance, right? I like what you said. It's the theoretical part. You have a 50-50 chance of getting a head or getting a tail. But let's talk about uniform, right? Let's say if you don't look, and I have a coin, right? And I say, hey Johnny, let's go ahead and bet. If I get a head, and Johnny doesn't look at my coin, you guys are listening. Alright? If I get a head, you have to do the chores for me. But if you get a tail, I do all the chores for you. And he said, bet, let's do it. You know how you guys say, oh, bet. Right? So when I flip the coin, it's not uniform because both sides are heads. But he doesn't see it.
You have 100% chance.
I have 100% chance, but he doesn't see it. That's what I'm talking about. So when I flip it, it was like, boom, I grab it, put it out, heads, I win. He never saw the other side of the coin.
What do you mean? Like when you do this?
The coin that I'm using, both sides has heads. He never saw that. Well, I cheated, right? But did he see that? But that's the part I'm trying to say. The part I'm trying to say is, in order for the theoretical to work, all right, in the experimental part, what are you using for the trial? It has to be uniform. It has to be an equal chance for all the sides to be. It has to have an equal chance of happening. So let's say in the experiment over here, you guys just told me a coin has a head and a tail, which is correct. So let's say this happens, right? The first 10 tries, we have head, 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 tail, head, tail. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then we have head, tail, head, head. So what's the probability of getting a head here?
70.
So are you guys telling me that the probability of getting a head, you have a 70% chance? Is that true or false?
You have a 50% chance, not a 70%.
The experiment showed that you had a 70% chance. However, the theoretical part says you should not have a 70% chance of getting a head. Instead, it should be a what? A 50-50 chance. Now, how many trials did we have here? 10. So we had 10 trials. If we were to increase this right here to 100, the more trials you have, the more aligned it will be to the theoretical part. If I do it just twice, 1, 2, 3, and I get head, 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 will it be 100% chance of getting a head? No. Experimental part, yes. Theoretically, no. But if I increase the trials, put it this way, the larger the number of trials, the more aligned it will be to the theoretical part. I repeat, the larger the amount of trials, the more aligned it will be to the theoretical part.
What do you mean aligned? You mean like more accurate?
More accurate to the theoretical of getting a 50-50 chance. So that's that part right there.